following recording is part 2 of a new podcast hosted by Matt Leary of Newgrange Design, Jeffrey Hazelet of FreedomCAD, and myself, Mike Buteau, of the Printed Circuit Engineering Association. Our guest is Jeffrey Leeds of Leeds AI, a consulting group focused on driving Industry 4.0 initiatives in the PCB ecosystem. Part 1 covered the printed circuit board supply chain. Part 2 looks at the future of the technology stack involving semiconductor die, packaging, and PCBs. As noted in Part 1, this podcast is so new, we don't have a name for it yet. We are open to suggestions.
From your perspective, coming 2 to 5 years, what do you think will have the biggest impact on the industry, the board level industry? What should we be getting ready for?
So, heterogeneous integrated packaging is where semiconductors is headed towards. And silicon is no longer king, right? It's the interposer. People try to say stuff like Moore's law is dead. Well, Moore actually kind of was like, hey, we're going to reach this limit with transistors where we're going to have to optimize the package. Right. And you're going to reach a limit with package optimizations. We're going to have to, get the system optimized. And that's essentially where we're headed. I think Matt Kelly at IPC has done a fantastic job of describing the silicon to systems directional movement. And in order for PCB manufacturers to be really competitive and really get on that cutting edge of tech is to say, okay, consider the package. Consider everything from gate to gate, right, on my PCB that I've set up on my PCBA, right, or from gate to antenna. How do I affect, or where do I sit in this whole system, and how do I bring benefit to that system? Because if you try to think, oh, I can build 20,000 of these things at this price point, you're not going to survive in North America. That volume is not going to immediately onshore. We don't have that capability. What we do have is the tech and the individuals and the ability to just innovate at an astonishing rate. So look at the tech stack, look at that innovation. How do I fit in that picture? And if you don't know how you fit in that picture, what data will help you figure that out? And I think that's going to be where you suddenly see PCB manufacturers really start to innovate and become critical to electronics again, is helping solve that issue. And that's where we'll see hopefully a nice little renaissance in North America. That would be my ultimate personal, that's where we're headed and what we should be focusing on idea.
All right, I got to admit that maybe 40 to 60 to 70% of that went over my head, and I would need you to back up. But if I could sum it up in a nutshell, packaging, is that fair to say? In 2 to 5 years, the changes to packaging will be the largest impact to the industry?
Correct.
Is that?
Yep.
Okay. And we need to come up to speed with what those changes are. What is the next generation in packaging and how that will impact the overall board, whether it's design, fab, assembly? That's where we need to set our sights. Is that a fair?
Yep. That would.
And where's a great place to jump off in doing that?
So, if you go and look,
coming up to speed,
any design, right? That's fielded in North America, I should say. What is your fundamental limit in pitch density and trace density that you can appropriately hit? Because right now, I think people look at board shops in North America and they're like, if you could do 300 millimeter pitch, right? Like that's good. We can't go anything lower than that because the North American supply base can't get there. Can't really go below 50 micron, right? 2 mil line in space because again, no one in North America can really get there sustainably and only a couple shops, so you're kind of locked in. If the entire North American supply base started to say, okay, how do we get to the point where we can help packaging and solve packaging ills? And that is taking some of that density that substrates and IC substrates are trying to translate between chip to chip and move that into the board. That's where that cost equation becomes really beneficial to them. So where and when scale occurs, right? So you've got transistor 10 to the minus 9, right? 10 to the minus 8 kind of occurring still within the same IC. You're getting down to 10 to the minus 7, just on the cusp of that, maybe, right around there when you're going from IC to interposer. And then the interposer has to bring it up to us at the micron scale, like 10 to the minus 6. So it's like, okay, how do we start moving into that density scale equation and doing so efficiently? I think that's going to be where, if you really had to look at it from a big picture point of view, how do you put some of that density onto the board in a cost-effective manner or in a systems optimization manner that will really be beneficial to them? Because they have their own challenges. They have their own things that they can't do. I can't take a 3 nanometer transistor and take it all the way up to a 300 millimeter BGA to get mounted onto a board, right? Like, it's going to go through several different scale changes before it even gets to you, right? It's going to go from IC, maybe a glass interposer, to an organic interposer, then down to the PCB, and in all of those steps, like, that's not sustainable to constantly do. And if the circuit board could figure out how to improve that density and scale function, that would be a huge value to the overall industry stack.
Okay, fantastic. Thank you.
Yeah. I'm going to touch in on this, saying we talk about packaging and we talk about the printed circuit boards, and what I feel, correct me if I'm wrong, but how you almost described it was, it's a separation of saying it's no longer going to be packaging and it's no longer going to be printed circuit board. It's that merging of the two technologies into one. That's the future of where we can make these leapfrogs in technology. Is the borders there have gotten blurred, and we need to stop segmenting it and saying, no, this is a package. He's like, no, now this is the printed circuit board. It's chip to chip with printed circuit board technology concepts, instead of putting that chip into its own package. And that's the interposer kind of concept of, I've seen some stuff about that where you're putting multiple chips together and you're effectively creating your own printed circuit board in this that now goes on to the printed circuit board. But if we could get to the stage where that's your whole printed circuit board, and that's what I've heard from some of these factories who are working into the very, very small ultra HDI concepts, that they're categorizing that technology as kind of this field. So is that how you see it?
Yeah, die disaggregation has been a trend for over a decade now, and that disaggregation effort is going to span not just across the die area and the interposer area, but it's going to start getting across the board itself. That is 100% where we are headed, and I think we have to look at technologies like photonics that might actually just like totally eliminate the need for the PCB in some of these really high speed and critical projects. Because if I could just put it on a laser and that laser goes from, IC to IC, and I get good data transmission and I don't have to go through the whole board, right? Absolutely, I'm going to go that direction. What's the criticality of that?
So in those cases, those glass bundles are going to become important again, not just for rigidity, right?
100%. Properly aligned in a good optical pathway for a laser to get from one gate to another gate at a chip level without having to go through a lot of boosters and subsystems to get out from like the 3 nanometer transistor. Yeah, absolutely.
So we should talk about that. We could maybe another branch of Lee's AI.
No, in fact, there's a photonics startup that I met when I was at an IMAPS event. I would love to talk about it, but it's like those waters are far deeper than what I understand. I understand a very skim surface level. She started her.
That's enough.
Yeah, maybe, but she's on the East Coast, and her she was a graduate. She got her PhD doing photonics. She has some idea. I can't describe it in too much detail, but for the last year and a half, she's been out there hustling, and I've been following her on LinkedIn, and they're slowly growing and growing and growing. And I think that's someone who you should, I'll find her name and send her over to you. But I think like those are the movers and shakers of that industry that are figuring out how are we going to make this tick and make this work. And she would be someone that I could think give you a lot of insight as to like where they sit in terms of how that industry is moving forward and how does that fit in the broader scale of the overall PCB industry, because there's cost to that, right? And the cost equation is going to dictate where and when, and we integrate that into the tech stack. But I'll grab her name. But she's that's who I'd say that'd be the next guest I'd recommend.
So, Jeffrey, if I'm hearing you right, what you're describing is a reimagined system on a chip.
Yeah, the system on a chip. Wasn't that like what 10, 15 years ago? That was like all the rage. Yeah. And we just it wasn't ready for its time in the sun, right? Like we still had optimization and gains and efficiency gains out of the transistor that were the most cost-effective way to get performance gains. Was to keep going transistor shrink. Well, we're at that limit, right? Like we are there. It is now moved to packaging. All computational improvement gains are from packaging. You can't do monolithic dies anymore. And that's what we can see out of heterogeneous integrated packaging. It's like the difference of $1 billion to develop a chip versus $300 million to develop a chip. That is why disaggregation is occurring. Cost function at that point and time function. So that system on a chip idea is definitely I would say finally coming into vogue, much like how IoT was around since 2000s, right? But we didn't have the infrastructure for millions of devices to suddenly call home on the internet. We couldn't handle that kind of bandwidth. What happens when 50,000, refrigerators at midnight suddenly decide to call home and send a data packet? You're going to kill whatever service is operating. But since then, we now have the infrastructure in place where IoT and meaningful large data aggregation at scale is easily accomplished. Like we're finally there, but the term IoT has been around for 20 plus years. And I'd say from that perspective of system on a chip, it's like, yeah, it's silicon to systems is 100% the direction we're headed. And I think now you are finally seeing that idea mature, much in the same way digital twins started out of product managed lifecycle, or product lifecycle management in the early thousands. And now finally this idea of digital twin as a concept being useful is finally becoming relevant, but it's taken, again, 20 plus years for it to occur.
And just to point out, like the Snapdragon chips from Qualcomm, those are system on chips, and that technology did come to fruition, and it is what it's strange to think of this today, but that is most a wide variety of chips out there do have that functionality, and now that's just a standard of this having all of these different components within it. Like I was looking at some chips the other day and was like, this has got a microcontroller as well as high-speed analog to digital and digital to analog converters and all of this functionality in the chip, and you're like, this is a system on chip. They've just been piecing these blocks together, and now you just need to get that kind of design, and this is commercial off-the-shelf chips for like $10, where you're like, before that was specific special ASIC design, you had to spin up your own chip to get that. Now it's like, go to DigiKey and order up 1,000 of them for $1 each. So it'll be fascinating to hear and see as the industry moves forward, though, of seeing chip to chip to chip to chip to chip instead of it. I mean, my electrical engineering computer hardware background, it's always faster the smaller and closer you can keep things together. So it will always be better the more you can just keep it on the silicon directly. But the modularity of being able to keep and build different chips together that aren't all that are commercial off the shelf, if you will, but then assembling them together. So could there be, you think, in the future, you buy the silicone and you send the silicone out to your packager, and now your packager is assembling 2 or 3 silicone chips together for you? That's something I don't see that's happening today.
Yeah, I don't think you're going to see anyone build out of silicone. They might build out of silicon, but maybe not silicone. An OSAT, yes, does do that. So, and they're struggling. you get down to the idea of KGD, known good die, right? Like if I buy this die from this person, this die from that person, that die from this person, they all meet the same spec for, let's just say, some adder or multiplication chip, right? How do I make sure they all work the same way for my system? It becomes a very difficult problem, and that is not solved. I'll say it like that. It's always been an issue since time immemorial for semiconductor. And it's only just going to get exacerbated as we move into a chiplet world, per se.
So thank you very much, Jeffrey Leeds, for participating in our podcast today. Matt, Mike, and I are very appreciative of the time you spent with us, educating us and enlightening us and our viewers on all these topics that you seem to be very knowledgeable on. You used words bigger than I think some of us understood and some of our listeners could understand.
SAT words.
Yeah. Woo. Yeah, SAT words. Those are more advanced than just SAT words. But we look forward to hearing about some of the things that you're working on now that you weren't able to share with us on the podcast. And we'll check in with you at another time. If those out there want to get in contact directly with Jeffrey Leeds, as you heard him say already, you can just Google him. So
Google, LinkedIn, probably put a link somewhere with my email, but it's just, Jeffrey at leadsllc.com. And that's Jeffrey, LEADSLLC.com.
And that's Jeffrey with a G.
And Jeffrey with a G. Don't forget that. It'll all be in the links. You can find me. We'll make it nice and easy. But thank you guys so much for having me on the pod today. Really appreciate, talking with other industry experts on like where we're headed. What's the vision look like? What are people doing? It was great to be around open and like minds. And I hope our listeners feel inspired and are looking forward to the future as well.
Great to meet you, Jeffrey. Thank you so much for being on today. It was great.
A pleasure. Thank you so much for your time, Matt.
Our guest has been Jeffrey Leeds of Leeds AI. On behalf of Matt Leary, Jeffrey Hazlett, and myself, thank you for listening.